In this video, we're going to be looking at the rest of the questions from the Chapter 4 and Chapter 5 review for Exam 3. Here we see question 23, where it says, you deposit $25,000 into an account that earns 5.2% compounded semi-annually, which means twice. So N here is 2. Find the balance in the account at the end of 5 years, 10 years, and 20 years. So let's start with our formula. Since we're just making one payment, we're going to use this formula, which is for savings with interest when you use just one down payment. That's your present value. So the future value in 5 years would be the current value, the present value at 25,000 times 1 plus the interest rate, 0.052 divided by 2, because it's compounded semi-annually, and then times 5. If we do this on Desmos, we get $32,315.70. So let's write that. So we write that here, $32,315.70. Then if it wants how much she would have, or you would have at the end of 10 years, you're simply going to plug 10 into your function for the years. Everything else stays the same. And when you do that, you get $41,772 and 19 cents, because you round to the nearest cent. Let's see what you get when you plug in 20. So when we plug in 20 years, we only change this part, the time, T, and we get $69,796.63 because we round to the nearest cent. Let's look at our next question. The next question, question 24, says Business Enterprises is depositing $450 a month into an account that earns 7.2% APR. To save up to the 25,000 they need to expand. How long will it take them to save up to 25,000 they need? So here they're making $450 a month, and that's a payment. So we're not going to use the same type of formula we used above. Also, they want us to find how long will it take them to save up to the $25,000 they need. That means we're trying to solve for time because we don't know the time it will take them. So if we go back and look at our formulas, we're either looking at this formula, the savings plan formula for future value, or the savings plan formula for payment. And the way we know that we're looking at one of those is because they are making payments. They're not just making one lump sum like we did in the last question. Now in this one, since we're solving for time, the variable t, we can use either formula. Let's go ahead and use this first one and see what we come up with. So we'd say the future value equals the payment times, in parentheses, 1 plus r over n to the nt power minus 1 over r over n. And this, let's go ahead and write that formula below, and then we'll work on it. So there's our formula. Let's identify the different parts we have here. It says they're putting $450 a month. So that's your payment. And into an account earning 7.2% APR. So that's your R, and we change it to a decimal, 0.072. To save up to the 25,000 they need, that'll be the future value. How long will it take them? So when it says how long will they take them, we're looking for T. Let's plug those into our formula and see what we can do. Here we have the equation set up, but we need to solve it. One thing we could do is divide by 450, and that would get rid of the 450 on the right side of our equation. If we do that, see what we get. I get 55 with a decimal repeating. So that'll look like 55.5 repeating, and that's going to equal this remaining part here, which is 1 plus 0.072 divided by 2 divided by 12, excuse me, to the 12t, and that's minus 1. That's all in the numerator. And in the denominator, we have the 0.072 divided by 12. Now, the way to get rid of this denominator is to multiply both sides of the equation by that denominator. So we're going to multiply 0.072 divided by 12 on the right side and on the left side. So let's do that and see what we get. Just a reminder, the reason for doing this is to get rid of that denominator there. That'll cancel it out. And on the left side, when you did the multiplication, you wind up with 0.3, and that just keeps repeating, is going to equal the 1 plus, oops, that's in parentheses, 0.072 divided by 12 to the 12t, and then minus 1. But since there's nothing else on the right side of our equation, I can get rid of the parentheses that surrounds the numerator. And to work on solving this now, we'll add 1 to both sides, so we isolate this exponential. On the left, that'll give us 1.3, and that's going to keep going, will equal this 1 plus 0.072 divided by 12 to the 12t. At this point, when we have our variable in the exponent, there are two ways to solve it. We can solve it by graphing, or we can solve it using logs. So let's see what that would look like. Graphing this, it didn't take too much manipulation of your window to find that the two cross at about 4.00756. So let's write that. It looks like the time it will take them to earn 25,000 is just 4.00756 years. Now on the exam, you could probably round that to about 4 years. I'll tell you how far to round it on each problem on the exam. But this is how it would look as a log, because we take the base of the exponent becomes the base of our log. The answer to this problem is written as the argument of the log. And then the exponent becomes the answer. So we can punch this into our calculator, and then when we divide it by 12, we should get the same answer as we got when we graphed it. Let's check. So a reminder, when we're doing logs of a different base other than 10 or e, it's useful to use the graphing mode, because there we have the log base a. So our base here is that weird number 1 plus 0.072 divided by 12. And then we're that in the argument, we had 1.3. Now that's what that equals, but remember, we wanted to divide this by 12. And we get that 4.00756 essentially. So let's see if that's the same. So you can see here that it is the same. And if we do solve it by graphing on your exam, draw me a sketch of what that graph looked like, because that's how you got it. If you solve it using logs, show me the log you used to get your answer. Let's go on and look at problem 25. In problem 25, it says you want to save $100,000 in 18 years for a college fund for your child by making regular monthly deposits. Assuming an APR of 7%, calculate how much you should put away monthly. and then how much comes from deposits, and how much from interest. So because it says you're making monthly deposits, again, it's going to be a savings plan formula. It also tells you how much, or asks you how much you should be depositing monthly. So when we go back up to our formulas, we're going to be using a savings plan formula, but in this one, we want to find the payment because it asked how much we'd be depositing monthly. So we're going to be using this formula. Let's go write that down and substitute the values in. So here's our formula. It says you want to save $100,000. You don't have that yet, so that's your future value, and it will go in here. And then 18 years away, so that's time is 18. That'll go in right there. And then you want to make the monthly deposits. You have a 7% interest rate, so R is 0.07. And you're putting the money in monthly, so N is 12. And that's this number in the bottom of the fractions. And we plug and chug. Let's see what we get. So when we plug that in, we got 232,000, no, $232.17. That's what you'll be depositing for each payment monthly. Then it asks how much of that $100,000 that you earn came from actual deposits. So the way you calculate that is you know that you put in $232.17 a month, 12 months a year for 18 years. So when you multiply those together, you get the total amount of payments. But then it asks how much comes from interest. Well, if you wind up with $100,000, if you subtract the money that you put in, you find that the interest that you earned made up the rest of it, which is $49,851.28. Dollar sign on that. And let's try our next problem. Question 27, excuse me, 26 says your bank offers you two choices for your new home loan of $820,000. So you know the present value. You are given a 30-year loan choice that has a 4.25% interest rate and a 15-year loan with a 3.8% interest rate. It wants you to compare your monthly payments, which means that's what you're going to be looking for, and the total cost of the loan and which loan you should decide to take. So if we go back up here, we're going to be looking at a loan formula. So that means we'll be looking at this formula here. Now this formula here, if you know what payment you can make, it'll tell you what loan amount that you can try to get. This one, if you know the current value or present value of the home, it'll tell you your payment. So this is the form we want to use because it'll just, if you plug the numbers in, it'll just give you the payment you need so you can find your monthly payments and the total of your monthly payments. So let's use this loan with both of those options below, or this formula with both those options below. All right, once we knew which formula to use, which we have up here, the principal or the present value of both of the loan options is the $820,000. So that goes there in our formula. R over N for the 30-year formula is 4.25% over 12. For the 15-year, they're only charging us 3.8% interest, so that's 0.038 over 12. In your denominator, you have this 1 minus 1 plus R over N to the negative MT power. So we have 1 minus, and then this part needs to be in a parenthesis all of its own, this 1 plus 0.0425 over 12. And then that whole bit gets taken to the negative 12 times 30 for the 30-year loan. And then the 1 minus this bit in the parentheses, the 3.8% divided by 12. to the negative 12 times 15 because that's our 15-year loan. When we multiply these out, your 30-year loan is only $4,033.91 a month only. Your 15-year loan is almost $6,000 a month. But to find the total cost, you take your loan amount times 12 payments per year times 30 payments per year for your 30-year loan. And for your 15-year loan, you take your payment, your monthly payment, times 12 times 15, because it's 15 years, and you get, almost $400,000 less. So that's how the difference can add up between a 15-year loan and a 30-year loan. All right, let's go on to problem 27. So you've decided to refinance your home mortgage to a 15-year loan at 4%. There we go, 4%. The outstanding balance of your loan is $450,000. Under your current loan, your monthly payment is $2610, which you must continue to pay for the next 20 years if you do not refinance. So let's find our new monthly payment for a 15-year loan at 4%. And then we'll see if we save any money by refinancing and how much interest will you pay on this new loan. We're going to be using the same formula as above, so let's write that down because we want to find our new monthly payment. So here you can see we have that formula for payment, and we substituted our values in here. So the present value is $450,000. The interest rate divided by 12 because they're monthly payments. And in our denominator, we had 1 minus, and then this part, 1 plus 0.04 divided by 12. That part alone was taken to the negative 12 times 15. Then we close the whole denominator. So let's see what we get on Desmos when we do that. Plugging that in here, I got 3,328, and I would make that 60. So let's write that. $3,328.60. Okay, now what is going to cost more? Will it cost more to do this for 15 years or to do our old payment, which we still had 20 years left on the loan? To figure that out, we need to multiply the 2610 by 12 monthly payments by 20 years to see how much we'd pay if we were still paying on that old loan. So here, when we multiply 2610, our current payment, times 12 payments here times 20 more years, we got $626,400. When we look at our new potential payment of $3328.60, and that's going to be for 15 years, so there are 12 months and 15 years, we get $599,148. So to find out how much we'd save by refinancing, we're going to take that $626,400 and subtract the $599,148. And let's see what that gives us. So it looks like if we can afford the new payment of $3,300 a month, that paying it off in 15 years at 4% will save us $27,252. Subtract the difference. All right. I hope this was helpful. Thanks for watching. Looks like there was one more question. So let's answer that last question. The last question says, let's see, make sure I'm sharing the right screen. Yep. It says, how much interest will you pay on the new loan? Well, you know, your loan amount was $450,000, and above we calculated that you're going to be paying $599,148. So by subtracting them, you find that the interest you'll pay on that loan is $149,000, 148. So thanks for watching, and I hope this is helpful.